Hey Professor Reza, it's Harlan, and this is my assignment 1 submission. I think it would be good if I actually put my student number up there. 1333838. So, this is my assignment. I tried setting it up in Google Colab, but I kept on running into issues with mounting my Google Drive and then actually pulling from the biostat CSV. Like I imported google.colab, mounted it, but I was running into permission issues and whatnot, and I spent about half an hour trying to get that to work, and then just kind of resorted to just using a regular Python environment just because I know that I can just get it to work right away. Which it did work right away, so I just continued to code in this environment, so I hope that that's okay. So to start off, I import NumPy and matplotlib as per the assignment requirements, but I also decided to import pandas as well because I wanted to utilize a data frame for 2 of the tasks. So let's get into it. Task 1, I initialize a new data frame using the pandas read CSV function, and then I take in biostats.csv. So that's task 1, easy peasy. And I just decided to do it with this method because that's what I'm used to with working on a couple of projects this summer. I just know it's a very powerful, I know it's really powerful, so I'd rather just use that. And then we go into task number 2, which is to pull the age column and store it to a NumPy array. And so I found this out doing research, but the data frame object actually has a method toNumPy, which takes that column and converts it to an array, which is super cool. So that's what I end up doing. So at this line, age column now is a NumPy array of the age column of the data frame. And then I also found that this method, since it's built into pandas, you don't need NumPy to make it work. But then if you want to work with the array anywhere else in the project, which obviously you would need to, that's when NumPy kicks in. For task number 3, it was a super simple just print. So I did a for age and age column. So it goes over each index of the age column array, and age becomes the value, so I just print the value to the screen. Once I do the console output, we'll see that. And then for task number 4, it kind of just shows how much functionality NumPy has. So I think that's the main takeaway from this assignment. The assignment overall is pretty straightforward, but I believe it's just to show how powerful these libraries are and how important it is to learn them. So for task number 4, as you can see here, NumPy has these built-in methods to their NumPy array objects. So we've got the age column, and to be honest, I wasn't super sure if average, min, max, and standard output were already existing. But I literally just put in the array, put a dot, and then just try to figure out what's available. So first I tried average, but that's not a thing. So then I checked mean is a thing. And then obviously min, max exist. And then for deviation, I was trying deviation, I was trying standard, and I noticed the STD, which I assumed was the right thing, but then I double checked with the NumPy documentation and confirmed that that was correct. And then what I just do here is a simple print. I put the labels just to make it a little bit more organized, and then since we're doing string concatenation, I also convert these numbers to strings just for the output. And we just call the built-in methods, easy peasy. That outputs, and I'll show that in the console afterwards. And then for task 5, I originally wrote it out and just printed a console, finished up task 6, and then was done the whole assignment in around 20 minutes or less. And I kind of just wanted to get a little bit more of a challenge to it. So I decided to redo task 5 and 6 and merge them together, because I thought that printing just the deviation to console doesn't really give a good representation, and it would be more beneficial to whoever's viewing the graph to just see it in the graph. So this ended up being a little bit more challenging, just trying to figure out how to properly do that, but I ended up making it as legible, as readable as possible. So what I do is I make a percentiles variable, and I'm using a method of the NumPy object. So before we were using methods of the NumPy array, now we're just using a method of NumPy, and that's percentile, and then you pass the NumPy array that you want, and then the percentile values that you want as well. So this is going to return multiple values, and the 50th percentile is going to be the median value in this case. And then when I first did it, I had it all the same color, and it was not super legible, so I decided to make some colors in here, and then I also made some labels so that I could plot it on a legend a little better as well. So the labels I have here, it's just super simple. It just kind of inserts what we have, almost kind of like hard coding it in. So it's not the most dynamic code. If these numbers change, the labels won't be represented properly. But I thought for the scope of this project, and since this wasn't really asked for, that this would be more than acceptable in this case. And then in terms of actually getting stuff done, I decided to use enumerate, because that allowed me to use the indexes of the colors, but then use the values of the percentile. So what we do here is, this is a new method to me, but in the plot, there's a method axvline, which plots a vertical line on whatever x coordinate you give. And that's what you have to pass. So I pass percentile as x. So in this case, the first iteration of the enumerate, the percentile would be 30. So we plot a line on 30, a vertical line on 30. And then for the color, since I'm using enumerate, I've got I would be 0 in this case, which would be red in colors. So we do color equals colors of index 0, or in I in this case. And then line style is just, you can choose between dash, dotted, and solid. So I just went with this. And then it loops through the enumerate, so each percentile gets a different color and gets plotted accordingly. So we'll call plot.axvline 3 times, because that's the amount of percentiles we passed. And then we just build the actual histogram. So we call this method here. We pass it our array. We pass it 10 bins. So bins is the amount of bars in the graph. So I counted the ones in the assignment. You had 9, but then a gap in between the final bit of the data and the first bit. So that meant that there were 10. I played around with different bins to see if it could kind of give you more or less information. But 10 does kind of seem like the sweet spot, especially since this data set's pretty small. Just to be different, I changed the color to purple instead of blue, like in the assignment. And then I added an edge color, which I've done in the past, just to kind of make it look a little more crisp. And then we do a title, a label for the X, Y, and then we make our legend. So I put it in the upper right corner, and then we just call our legend labels, which we've made up here. And then we show it. So I'm going to run this code. Pi. Okie dokie. Exciting. But let's look at the console first. So see, we get the output that we were looking for. That's just that print up here for task 3. Then what we get is the average, the deviation, the min and max value. So to confirm that, 23, 53, we can see in the printout, 53 is our biggest number. And where is 23? It's there. There we go. There's 23. So that's all worked correctly as expected. If we go back to our plot here, so we've got it all plotted, and so the shape is very similar. No, it's identical to the assignment document. And then what I've added here is just that deviation. So we see red is our 30th percentile. Its value is 30, and that's because it's plotted right on 30. Then we know that our median is a 32. And then our 70th percentile ends up being 37, which is plotted here. So that is everything I have. I've also used Git this entire time, so I'll submit my GitHub repository link just so you can see that I've committed everything accurately. I tried to make a commit for each task, if that shows anything. And yeah, thank you for watching. I hope you enjoy the rest of your day, and I will see you in class.